vision of IFaCOM is to achieve near-zero defect manufacturing to save resources in the manufacturing of high-value parts, custom design manufacturing, and high-performance products. IFaCOM brings into the market intelligent sensors, signal analysis, and self-correction in real time. Through analysis of multiple sensor data input during the manufacturing process, parameters are continuously optimized to increase overall performance and stability.
For Europe, as a high-cost region, making very many high-end products with advanced processes, in addition to focus on the costs, it's very important to do the manufacturing with zero defect.
In the aerospace industry, 2 end users have implemented IFaCOM solutions in their production lines. The first, GKN Aerospace Norway, manufactures a turbine rear frame for jet engines used on Dreamliner and the new 747. Currently, the fabrication process utilizes manual labor by highly skilled operators for the initial placement and fastening of the subcomponents. IFaCOM technology will automate this process and create a robust assembly process that reduces non-conformance downstream. IFaCOM applies sensors that monitor the assembly process in real time. The automatic feedback of assembly data from production allows for a minimized and uniform stress state in the structure, thereby reducing welding defects. The software also provides aggregated data for in-depth process analysis to achieve a more efficient workflow method overall.
We now have a very good specification of what we need, what we require to industrialize everything that has been researched and developed within IFaCOM.
The second demonstrator in the aerospace industry is EMA. EMA manufactures turbine components for jet engines and power generation. An important source of defects is the ceramic inclusion in the super alloy components. These inclusions come from the ceramic shell mold in which the molten metal is poured into when casted. Effectively controlling the primary slurry during the shell making is a complex process, and improvements are needed to guarantee the best integrity of the ceramic layers in order to reduce the inclusions in the turbine components and related scraps. IFaCOM's technology now allows EMA to employ new equipment to effectively control the ceramic slurry mixture, thereby reducing time, costs, and chemical consumption.
In the IFaCOM project, we treated the problem regarding the ceramic mold manufacturing. The solution adopted for that, with a benefit to decrease 80% the cost and the chemical reduction for this kind of equipment, and decrease the number of scraps.
In the machine tool industry, 3 end users have implemented IFaCOM solutions in their production lines. The first, GF Agi Xiaomi, is the world's leading provider of machines for the tool and mold-making industries. The sophisticated wire electric discharge machines that form hard metals into parts can leave lines and marks on the surface that cause parts to be rejected. IFaCOM's intelligent sensor and regulator system registers vibrations in the wire and the part. The innovative signal processing system interfaces with the CNC router to anticipate 3 types of defects, and statistical analysis localizes the potential defect place in the part. A regulator reacts in real time to prevent such defects, thereby assuring quality and reducing scrap. With IFaCOM's innovations, Xiaomi expects to enter the growing Asian aerospace market.
The IFaCOM project has been a key project for us to develop a system which guarantees a perfect quality of the surface, a zero defect, which is a basic and a fundamental demand of these industries.
The second demonstrator in the machine tool industry is Alesemonti. Alesemonti is a small Italian machine tool manufacturer specializing in boring milling machines. Structural components are manufactured in-house using their own machine tools. Accurate fitting between components is ensured by hand scraping performed by skilled workers, and typical applications include small and single-batch production of very expensive parts. The IFaCOM Solutions Toolkit strongly supports the user in making the first part right. IFaCOM sensors continuously monitor variables such as ambient temperature, load, thermal energy transmission, and tool insert wear. The software module predicts geometric errors and compensates them in quasi-real time, allowing a 50% reduction of machining tolerances.
The results from IFaCOM are twofold. The first result is the application of what has been learned, or the toolkit of solution applied to our manufacturing process, and the inclusion of those tested results within our product and service offering increasing the capability of our customer to become competitive.
Strecken is the third and last demonstrator in the machine tool industry. Strecken in Denmark manufactures the RAP polishing machine. Traditionally, the polishing process is blindfolded so that time-consuming post-polishing surface quality assessments must be made. The IFaCOM sensor suite monitors the polishing process in near real time and can register process defects and incidents such as polishing stone breakage or tool shaft bending that could damage the part if not reacted to. By integrating surface measurement, instruments and parts can be automatically inspected while mounted in the production equipment, guaranteeing known good units.
Instead of having these stop-and-go situations, we can say, now this part is okay, give me the next one. That is a breakthrough in this polishing technology for us.
Through sensor fusion and signal analysis, IFaCOM allows European companies a completely new grasp of their manufacturing processes, enabling them to stay competitive with near zero waste of resources.